Kia ora. Welcome to the incredible KRAFLA volcano. During this series of exercises and videos, we will explore volcanology and geothermal energy at KRAFLA in Northern Iceland. First, you will learn geological skills, how to record systematic and detailed observations of an outcrop and a rock of obsidian and fine-grained rhyolite. You'll learn how to compare the geomorphology of tuff cone and caldera volcanoes. You will then learn about intrusions in caldera settings in other parts of Iceland and how to integrate this knowledge to the KRAFLA volcano to judge conceptual models of the magma beneath KRAFLA. To help you judge these models, you'll need to learn how to apply some geophysics and compare the implications of different geophysical datasets to illustrate the uncertainty associated with the magma chamber size and shape. KRAFLA is a fissure swarm and caldera volcano with a remarkable and varied history of eruption, geothermal exploration and folklore about trolls. The fissure swarm is basaltic in composition, about 90 kilometers in length and not much more than 10 kilometers at its widest. KRAFLA is located right next to the plate boundary, where the crust is being stretched at a rate of about 18 millimeters per year. About 100,000 years ago, large eruptions of rhyolite produced pyroclastic flows and blanketed the surroundings in spatter and scoria, lapilli and ash. In the 19th century, a series of basaltic eruptions reached Mývatn Lake and caused secondary phreatomagmatic eruptions, producing the breathtaking series of cones that occupy the area around the lake. Some of these old lava flows are now a series of ragged crags and peaks, which, according to locals, are petrified trolls that were partying too hard and forgot to hide when the sun rose. Geothermal power generation started in the 1970s, but was soon interrupted by a series of basaltic eruptions in the late 1970s and early 1980s. These eruptions were known as the KRAFLA fires and occurred as lava fire fountains and flows that erupted from a series of fissures to the north of the caldera. By the end of this event, the KRAFLA rift had become up to 9 meters wider in certain locations. Given this amazing activity, it's not surprising that KRAFLA is the proposed site for the world's first magma testbed. It sounds like science fiction. A group of scientists from all around the world are planning to drill into the magma beneath KRAFLA in an attempt to harness the awesome energy of the volcano. Before we give you the tools and information you need to achieve these learning goals, we want to show you how this part of the field trip builds on your prior knowledge and skills. Answer these questions to move on through the virtual field trip. Let's get started.